Okay, we're now going to have a look at the answers to the other questions on the test. Remember that you're always best to have a look at the questions first and see whether you can do them before you look at the answers. If you're really stuck, I guess you can watch the answers straight away, but you're much better looking through your notes and everything first in order to work out the answers. Alright, so let's have a look at question number 1. So it's saying, explain what happens to the electrons around the aluminium and the fluorine atoms when they react to make a compound. I might just draw a couple of diagrams and just do before reaction and after reaction so we can see the difference between the electrons. There are many ways you can draw this. Some people might actually want to draw it in shells. They might actually want to show the electrons being transferred from one atom to the other. I'm just going to do it by showing the numbers. So before the reaction I've got aluminium, and aluminium sitting here has got 27 protons and neutrons, because that's its mass, 13 of which are protons, so there must be 13 protons, 14 neutrons. So I've got aluminium sitting here, and it's got in it 13 protons and 14 neutrons. And around it, it's got therefore 13 electrons. And I've got 3 fluorine atoms. Each fluorine atom has got 9 protons, 10 neutrons, because it's got a mass of 19, and it's got 9 electrons. So there's 3 of them, 9p, 10 neutrons, 9 electrons. Okay, now we can see here that the closest noble gas for both of them is neon. Neon's got 10 electrons, so aluminium will lose 3 and each of the fluorines will gain 1. And that tells us that the formula of the compound has to be aluminium fluoride, AlF3, because each of the fluorines is gaining 1. So if I show it after the reaction, then what happens after the reaction is I've now got my 13p, 14, but this time, I'll show it in a different colour, I've only got 10 electrons, because the aluminium has lost 3 of them, and each of these fluorines has gained 1. So each of these fluorines gets 10 as well, and everybody's got 10, and everybody's happy, which is why this is what the compound looks like, 9p, 10n. Sorry the stylus is not making it easy to read. I'm having great difficulty writing small. And then finally, the last atom. And this time, we've got 10 electrons. Which means that this one is Al now 3+, because it's lost 3 electrons, and each of these are an F-. This is F-, that's F-, and that's F-. So each of these have gained an electron, so they're now negative, and the aluminium's lost 3. And that's the basic explanation. There's many different ways of drawing this. If you've drawn it a different way, but it's saying the same thing, that's absolutely fine. Alright, now we get onto ions. Remember, ions are atoms that have either gained or lost electrons, so they're now charged. When I have a plus and a minus, they will totally balance. So I'll get KOH, KCl. Now I've got 1 plus and 2 minuses. So sulphur's trying to gain 2, but each of the potassiums can only give 1. So I need 2 potassium atoms, each giving 1, for this to work. With the mercury 2, it's the other way around. For the mercury 2 ion, it's losing 2, but the hydroxide ion is only gaining 1. So this becomes Hg, got to have 2 hydroxides. Notice if I'm repeating the whole combination of elements, and I'll put it in brackets like that. Again with this Hg, I don't need to put this one in brackets because I'm just got a single element here, chlorine, And the last one, they should perfectly balance, the 2 plus and the 2 minus. So that's what I do with this. If I'm naming these compounds, KOH is potassium hydroxide. So you'll need to go and look up your periodic table to find that out. Oops. I don't know how I changed colour there. I'll change colour back to what it was. K2S is potassium sulfide. HgOH2 is mercury hydroxide. Now mercury can be both 1 and 2, so it's mercury 2 hydroxide. The other one is mercury 2 chloride. I'll move the whole thing up. Chloride, and the very last one is mercury sulfide. Again, mercury 2, move it up again. Sulfide, again look at your periodic table to satisfy that out. Which of the compounds are soluble? Again, we need to now go to our solubility rules and to read that through. And if we have a look at our solubility rules, I'll just go and bring them up here on my computer so I can see them to make sure I don't make an error. If I go and have a look at my solubility rules, I can see quite clearly. If we start off with this one over here, KOH, it says alkali metal group 1 compounds are soluble. That means lithium, sodium and potassium ion compounds are soluble. Here I'm looking at the precipitation sheet on page 2 in the going further section. So this is going to be soluble. So we can write soluble to here. I'll write S for soluble and I for insoluble. So I might just have S is equal to soluble, I equals insoluble, and I'm just going to go back to the table above. So this compound is soluble. KCl again has got potassium, so that's got to be soluble. Potassium sulfide's got to be soluble. Now we go to now the mercury one. Most hydroxides are insoluble. The exceptions are the alkali metal hydroxides and barium hydroxide. Calcium hydroxide is slightly soluble. Well, we've got mercury 2 hydroxide, so that's got to be insoluble because there's none of those. Let's go to the chlorides one. Most chlorides, bromides and iodides are soluble with the exception of those containing silver, mercury 2 and lead 2. There's actually a misprint in the information which I got from the internet. It's actually mercury 2 chlorides are soluble, but according to your information we'll say insoluble because that's the information you've got. But the correct answer is actually soluble there. If you're looking at it, there was a slight error on your sheet. And finally, mercury sulfides, carbonates, phosphates and sulfides are insoluble with the exception of the alkali metals and the ammonium ion. Well, it's not alkali metals, it's not ammonium ion, we've got mercury 2 here, so that's got to be insoluble. But I just want to point out that this one actually is soluble. There was an error on your sheet, on the precipitate sheet, and this is actually soluble. It's actually mercury 1 compounds that are insoluble, not mercury 2. So if we're technically correct, mercury 1 chloride is insoluble, but mercury 2 chloride is soluble. Okay, so that was my mistake, my apologies. Okay, next slide. Well, just before I go to the next slide, as I made the mistake, if you had written insoluble here, I wouldn't mark you wrong, because with the information you had got, you were making the logical choice. Okay, now we get to a slightly more complicated question. If you look at copper on the periodic table, you will notice that copper is the 29th element, and it's got a mass of 64, which means it's got to have 29 protons and 35 neutrons, because 29 and 35 make 64. So if I was sketching copper in the nucleus, I'd put 29p and 35 neutrons. I'm going to, rather than draw individually electrons, I'm now going to just draw them in terms of what you'd see in a shell. So in the first shell, I've got my 2se electrons. So my first shell I'm going to write as 1s2 to say they've got 2e electrons, and that's my first shell. In the second shell, I'm going to have 2s2, which is my 2s electrons, and my 6p, which makes 8 for the second shell, which is what we know makes up the second shell. For the third shell, I'm going to have my 3s2, my 3p6, and then I'm going to have some d's. But I don't know how many yet, because I know that after my p's I start filling off the fourth shell, so we'll leave some space to write the d's a bit later on. And then in my fourth shell, I'm going to only have 2 s's, because I haven't filled up any p's yet, because the moment I go to the moment I go beyond calcium, I go back again. So the fourth shell has just got 4 s's in. So all up I need to have 29 of them. So I've got 2 and 8 makes 10, and another 8 makes 18. Then I've got the 19 and the 20, which are the 4 s's, but I've got to get up to 29. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9. So there must be 9 D1. So we'll write 3D9. Third shell, 9 D1s. So that's copper. So this is all copper. This is copper 2 plus. You can see the 2 plus comes from the 2 electrons in the outer shell, because there's 2 Se electrons in the outer shell. Chloride's fairly easy to draw. Chlorine is got 17 protons, and it's got a atomic mass close to 35, so that's 18 neutrons, and each of the atoms will have, therefore, going into the first shell, there'll be 1 s2, because there's only s electrons in the first shell. Next shell will be 2s2, and there'll be 6 p6, and then its third shell is going to have 2, but now, because it's only got 7 in the third shell, there's only 5 p electrons, because 3 and 5 make 7, and that's the third shell done. I'll draw the next chlorine atom down here, same deal basically. I'll draw the next chlorine atom down here. One S2, 2s2, 2p6, so 8 in the second shell, Third choice only you're going to have 7 in, so it's 3s2 3p5 and 2p5. Now these are before they combine, so when they combine, copper loses its 2, so these two will, so at the moment I haven't really drawn copper 2 plus, I've just drawn copper. So if I want to make a copper 2 plus, I've got to get rid of those two, and I've got to add an extra one to the chlorine, so this becomes a 6 and this becomes a 6, and now I've drawn the ions out properly, so that becomes a 6. Get rid of that one goes, and these go. So copper loses its 2 outer electrons and chlorine gains. Now there's many different ways you can draw this. I've just shown you one way here. I hope that makes sense to you. Okay, thank you.